Hi, some of you asking about this pressure problem in Webworks Homework 2, Problem 4. Now let's take a look at how do we tackle this. This is a weather balloon carries mercury barometer, determine the altitude as a function of flight time. So at one time, the barometer gives reading at 630 millimeters. So let me write it down. That's going to be the height about this mercury Hg in millimeter, right? We know this is something we know, like at 1 atmosphere pressure, right? It's if you change to mercury height, that's about 660 or 780 millimeter mercury. And so this is 630, which we know the pressure actually is lower. We do know because when you get higher altitude, your pressure actually drops. So this is reasonable. You have 630. So they ask you how high this balloon has traveled. And they give us the density of the mercury and also give us the density of the air. So knowing this very basic principle, at higher altitude, the pressure drop. So how about what's the pressure at this higher altitude? It's going to be rho mercury G H mercury. That's going to be the pressure there. And this is a pressure there, but thinking about at the sea level, that's going to be the atmosphere pressure. So that's going to be 1 atmosphere pressure. And the higher you go, the pressure drop. How much it drop is depending on this rho air, because we're at the air now, right? That's going to be the fluid, rho G and H. This is going to be the H you're solving, how far this has traveled. So that's what we're solving. Now let's go ahead put our few values here. The mercury is 13,600. And G, if we're going to remember for thermodynamics, you're going to use G as 9.807. Sometimes it matters. And H, this mercury height, they told us the reading is 630. However, it's in millimeter. So I'm going to change that to meter. So it's divided by 1,000. Because we know rho GH in one of the videos we're talking about, that should give us in unit of Pascal if you use the standard unit, which we use meter for H here. That's going to give unit of Pascal here. Now, 1 atmosphere pressure, we know that is 101,325 Pascal. Then the air density is 0.9, which is given here, and the G and the H. Again, let's go ahead and write down our G. Oops. Our G here is 9.807, and the H is what we are solving. So for this situation, we go ahead and solve our H. Oops. So our H is going to be this value, 101,325 minus rho mercury G, mercury rating 0.63 meter, which is 630. Then we'll divide by 0.9, that's air density, and divided by G. That's going to be the height. That should give us a unit of meter. And our unit should works because again, here is Pascal. You change the millimeter to meter, and here is already given in Pascal because it's 1,325. And here, what you solve for H should be in unit of meter. So that's all for this problem. So go ahead and try out your numbers, see if that works for you. All right, see you next time. Bye.